Good day, friends. This series is about to understand Indian energy scenario. What is Indian energy power consumption and where India stands compared to global energy power consumption? That is being compared in this first lecture. We are going to see in this lecture about what is energy scenario, some facts about India and its energy consumption, basic classification method of energy, what is a definition of energy audit that we will see, and then we will have some statistics about Indian energy scenario. When we say a word energy, it is basically a technical term used for a capacity to do work. Whenever some force is there which has a capacity to do work, that we call as energy. This energy has multiple use. In general, form of energy is electrical energy that we use from a basic purpose of starting a bulb to run our mobile, to charge our different systems, to use electrical appliances, to use food, to keep the food refrigerated, and for many other applications. So among almost all type of energy, electricity being most common type of energy. Reason behind that is electricity is easy to transmit, easy to store up to an extent, and easy to control. Compared to any other form of energy, this advantages has been just possessed by electrical energy. So that is a very reason for energy which is used conventionally, that is electrical energy, or we call in short as electricity. Any energy or energy consumption of the country, that is basically representing three growth aspects of a country. First, it represents economic growth. Second, it represents social growth. And third, it represents political growth. So, based on energy consumption per person per capita, these three growths are being indicated. So, these three indicates or indexes they are using, and per person energy consumption is considered for that. We should know about certain fact about Indian energy consumption. For a population which is more than 1.3 billion, we have more than 17% world's total population. So on a population map of world, we have more than 17% possessed by India. We are fifth largest consumer of energy. Then we are increasingly depending because of us being a developing country. This makes it continuously consuming more and more energy. On India or on world map, if we consider, then we occupy 3,28,000 kilometers square. Then we have seen that expansion in last five decades. Energy consumption has been exponentially increasing in last 5 decades, and that is very much high compared to previous energy consumption pattern. So knowing about this fact, we are going towards how to conserve the energy. Energy conservation and energy saving, they are seem similar, but they are bit different. When we say energy saving, it means that we are reducing the consumption. And when we say energy conservation, it means that we produce the same task, we complete the same phenomena, but with the less consumption of the energy. So when we say energy conservation, we don't negotiate with the use of energy, or we don't negotiate with the process, same product manufacturing, we do get it. But for that, when we use energy in a way which is producing the same output but with the less input, then we can call it as energy conservation. Biggest advantages of energy conservation is we will be able to conserve our resources. Three main benefits are there. We will be having our resources well maintained. We'll be using it optimally so that it can last for a longer duration. Second is cost saving will be achieved whenever a production or a manufacturing or a performance is carried out with the less energy conservation, with less energy use or conserved energy, then the cost of end product or the process will decrease. And third and the most important point is whenever we are conserving energy, we are creating good impact on the environment. Whenever we use the energy, with it many other pollutants are being formed. If we are talking of electricity which is generated from coal, then that coal when burned produces carbon dioxide, sulfur dioxide, and many other pollutants to the environment. So those pollutants are affecting environment by one or other way. So whenever we are conserving the energy, it is very obvious that we will be using less amount of energy for the same process of the production. Hence, its energy consumption is also reduced as well as environmental effect is also less. Energy conservation has also advantage of energy security. If we perform the process with the less consumption, it means that availability of energy will be there for a longer duration. So hidden advantage of energy conservation is energy increasing energy security also. If we can reduce 10% of energy consumption, then it will lead to 200 millions of less carbon dioxide produced. It will lead to cut of 1.7 million tons of CO2 produced, and then it will also lead to 9,000 tons of less nitrogen to be produced per year. In general, classification of energy is basically by three methods: primary and secondary energy, commercial and non commercial energy, and renewable and non renewable energy. When we say primary and secondary energy, it basically classifies based on the availability. Energy which is available in a raw form, in a natural form, we call it as a primary energy. It can be a wood, it can be a fossil fuel which is there beneath the layers of the earth. Those energy are called primary energy. While secondary energy is when we convert this primary energy to the more usable form of energy, more convenient form of energy, then we call it as a secondary form of energy. In this diagram, it is shown that oil which is excavated will be refined, it will be transferred to electricity, and then it is going to domestic applications or industrial applications. So we are converting coal to electricity and then finally using it at either home or industrial applications. Then the primary energy is getting converted to secondary energy. Just like that, there is commercial and non-commercial energy. The difference is when we can buy the energy, then it is called commercial energy. So energy which is used by industry or by domestic application, and for that billing is done, then it is commercial energy. While non-commercial energies are those which are naturally available free of cost and people can access it without paying for it. Say for example solar energy, that is the best example of non-commercial energy. Either it is used for industrial application or it is used in farming or agricultural, same way, but it's not been paid to the nature, hence it is non-commercial energy. Just like solar energy, there is a wind energy, wood when it is non-commercial one. So these are the examples of non-commercial energy. And last classification is renewable and non-renewable energy. Renewable is the one which we can use again and again. Say for example, hydroelectricity is converting water capacity, potential energy in the water gets converted to electricity. So that is an inexhaustible. Same water can be reused. Wind energy or solar energy, same energy can be reused again and again. And once utilizing, we are not creating any impact on environment. So when such energies are there which is not creating impact on environment as well as which is available in ample form without the main source getting reduced, it is called renewable energy. While non-renewable energy are the one once using it, it cannot be used again. Say for example, when combustion of petrol takes place in engine, then the gases produced cannot be used again to produce further energy. Hence, it can be used once, as well as whenever we use it, it has a huge environmental effect. Most of the case, negative environmental effect. So it is non-renewable energy. So basically, just summarizing classification of energy, basically we can classify by three methods: primary and secondary energy, that is based on its availability; commercial and non-commercial energy, that is based on billing or non-billed energy; and renewable and non-renewable energy, that is based on availability in nature or we can use it again and again. That is how classification of energy is done. Now, why we are studying this energy scenario, very reason behind it is we want to go for energy audit. So energy audit is basically a process performed on energy which has been used in plant or in a process or in a premises wherever energy is used, any type of energy is used, they need to go for energy audit. So as per Bureau of Energy Efficiency and as per Energy Conservation Act 2003, whenever a utility is there which is consuming power which is more than 500 kilowatt or it has got a connection of more than 600 kVA, then they have to go for energy audit. So this is a mandate that when this much of requirement or this size of connection is there, energy audit is must. So now friends, we should know that what is energy audit. Energy audit is a process of man- analyzing, verification and monitoring use of energy, documenting it and then generating a report based on it. That report should have further about knowledge about what should be done next, and then we have to verify that whether those changes are being made or not. So this process is called energy audit process. Energy audit is first step towards understanding how energy is consumed. Just like financial audit, energy audit is extremely important because it will give us a guideline that whether in a plant or in a factory, energy usage is as per the law, as per the rules or not. And one more thing I would like to add over here, it is always said that when we cannot create a single watt of power or when we cannot create a single drop of oil, we don't have freedom available to use energy without auditing it. So energy audit from that concern also very much important. It energy audit gives potential indication that whether an energy saving is possible and which particular segment of industry or a plant has energy conservation opportunity behind it. So energy audit is not only a mandate for a company, but it also gives us a light towards a direction that this particular process is using more than the required energy. Hence, if we can conserve the energy, if we can rectify those process, it can ultimately lead towards saving, and that saving will be ultimately getting converted in profits. If we compare life cycle emission of different modes of fuel, it is like this. Coal has got largest emission and wind and solar has got lowest. So tons of CO2 or equivalent produced when gigawatt hour of energy is being produced by coal. As you can see, it is largest. Compared to that, natural gas has relatively low and all other non-conventional energy has a minimal tons of CO2 equivalent produced. So obviously we should always go towards this type of energy and that will limit the amount of CO2 to be added to the environment. CO2 added to the environment is ultimately making impact on environment in many fold, right? So CO2 reduction will not only have a less environmental effect, it will also reduce ozone depletion. It will also have less damage to earth environment. Another thing to note over here is transmission and distribution losses for our country is highest. If we compare other countries' transmission and distribution losses, compared to that, we are almost having 5 to 6 times and this losses. And ultimately, this loss is to be bared by the consumer because of faulty or inefficient transmission structure as well as because of theft which occur in the transmission line, we are paying 5 to 6 times T&D losses compared to other world countries. If we talk about Indian energy scenario, then out of total energy produced, 62.8% is coming from thermal energy. This thermal energy is made of coal, gas, lignite, which is other type of coal, and diesel. Diesel is very small. Compared to that, coal is maximum and then comes gas. So this all forms a major chunk of energy produced, which is again non-renewable, and that is contributing to almost 63% of our total energy consumption. This is all data collected around March 2020. Then another source of energy production, that is hydroelectric power plant, then comes nuclear power plant, and then comes rest, that is solar, wind, and all other renewable sources. This is as per MNRE data, S- Ministry of Science and Renewable Sources.